Okay, number 34 is an equation, it's a logarithmic equation. My recommendation is to simplify each side. So the first thing to do is these are natural logs, which means base A. That's going to be 7x squared plus 4. There's not much I can do about that. I'm going to bring the 3 up. It's going to be natural log of x cubed. And what does that equal? The natural log of 4. Let me keep going through it. And what do I see over here? I see natural log of 7x squared plus 4 over x cubed. I'm using the rules of logs to do that. Natural log of 4. What do I know about this over here? If these logs are equal, this must be true. All right? Before I say that, though, I want to point out there is some tricky nature to this over here. This has got to be a positive number. Now, certainly when I go back and do the problem, we'll talk about that by checking it. And how do I do this over here? Wow, this looks like a tough one, doesn't it? It's a cubic polynomial. So let's write this down. I got 7x squared plus 4 equals 4x cubed. All right, so I got a problem right now. The problem is I'm looking at this thing and I wonder how to solve it. And we're going to go back to what you learned in Math 119. So 4x cubed, let's see, minus 7x squared minus 4. And looking at that, rational root theorem, I'm using the rational root theorem, and I'm looking for roots to it, and they're rational. I'm going to look for easy ones first. I'm going to look for the factors of 4, like 1, 2, and 4. And looking at 1, that's not working out. Minus 1 wouldn't work out. 2, let's try 2. So I'm going to say, maybe x equals 2 as a root. It's in the list of rational roots, by the way. Let's write this down. 0 equals 4. 2 cubed is 8, minus 7 times 4, because 2 squared is 4, minus 4. What do you get there? 32 minus 28. 7 times 4 is 28, minus 4. This, in fact, does equal 0. So I got a root now. So if I have a root, I'm going to write this down, I can get the other factors. And how many factors are going to be? Well, it's going to be 3 factors or 3 roots. Let's go for that. So I'm going to say x minus 2. I'm going to use long division now. 4x cubed minus 7x squared minus 4. Let's write this down. I'm going to put down 4x squared. That gives me 4x cubed minus 8x squared. That's not so bad, right? And then what do you get? Let's take a look. You're going to get x squared minus 4. Now, let's keep going. What I'm going to do now, I'm going to add x. And what do you get there? X squared minus 4x. I'm sorry, I made a mistake there. It's going to be x squared minus 2x. You're going to subtract. What do you get there? 2x minus 4. What do you do now? Well, it looks like 2. So what do you get? 2x minus 4. Well, as expected, 0 remainder. So I'm going to claim over here, I'm getting close. I'm looking at the equation now, 0 equals, and I know it's x minus 2, and then what do I get over here? 4x squared plus x plus 2. All right? This looks like a tough one, and the reason I'd say it looks tough to me, I got one of the roots, I got x equals 2. By the way, if you want to go back and check it, let me do that before I say anything. It's a natural log. Well, 2 would give you 4. 4 times 7 is 28. 28 plus 4 is 32. Minus, this would be the natural log. I'm bringing the 3 up, and there's a 2 there. It would be 8. And now would be the natural log of 4. And that does stand to reason, because 32 divided by 8 is 4. It stands to reason. Right? I want to see if there's other ones, though. All right? So what do you mean other ones? I'm looking at this guy over here. Whoops, sorry about that. And I'm wondering what the roots of that are. All right? Let's go through that. And write it down. So what do you get? 4x squared. I'll use quadratic formula. Let's see, twice the a, which would be 8, minus the b, which is minus 1, plus or minus. And what do you get? The b squared would be 1, and then minus 4 times 4, let's say 4ac, right? So 4 times 4 is 16, 32. What do I know about these? These are complex. So we've only found one real solution, and that real solution is x equals 2. It's the only real solution I found. These over here are complex, so we don't use those. Thank you.